Welcome to today's deep dive. Our mission today is to unpack the GCP Security and Compliance Services Guide.
Right. Yeah, it's a massive stack of Google's documentation. We are basically trying to figure out exactly where their responsibility ends and, well, where yours begins.
Exactly. So to start, I want you to imagine, like, leasing space in this massive, ultra-secure automated warehouse. Google owns the building, the security cameras, the robotic forklifts.
But the padlock you put on your specific storage crate, that is entirely your responsibility.
Yeah, that's entirely on you. And that structural split is what we call the shared responsibility model, right?
Yep, exactly. Google handles security of the cloud, so the physical fiber networks, the custom hardware like their Titan chips, but the enterprise handles security in the cloud.
Like your access policies, your encryption keys.
Basically, yeah, setting your own padlocks.
Right. And, setting one padlock is easy. But if you're an enterprise architect, you aren't managing just one crate.
Oh, definitely not.
You're managing thousands of them across this massive global network. So how do you actually ensure every single lock is engaged without missing one day after day?
Well, you really need a central nervous system for that. In Google Cloud, that's the Security Command Center, or SEC.
Okay, so SEC.
Yeah, and it doesn't just passively watch, it actively hunts. For example, it runs security health analytics, which is just constantly scanning your infrastructure's configurations.
So it's looking for mistakes.
Exactly, human error. Like, say a developer accidentally leaves a storage bucket publicly exposed, it catches that.
Okay, let's unpack this. Because scanning configurations makes total sense for static mistakes. But what about active attacks?
Right, the live threats.
Yeah, because a misconfigured bucket is one thing. But a live hacker actively trying to break in is a completely different story.
And that is exactly where event threat detection kicks in. It takes in your continuous logging streams and applies machine learning models to spot anomalous behavior.
Oh, wow. So it's looking for patterns.
Right. If a script is trying to, brute force your IAM, your identity and access management permissions, or silently execute crypto mining code, SEC flags it based on the behavioral pattern. It isn't just relying on static manual rules.
I mean, I saw a feature in the notes called attack path analysis, but networks change by the second. Does this actually draw a real-time visual map showing how a hacker could hop from a forgotten entry point straight to a database full of PII?
It does, actually. It's continuous and dynamic.
Wait, really? It updates in real time?
Yes. It evaluates your actual, currently deployed resource dependencies and visually maps the exact route a bad actor could take.
So it's literally showing you the domino effect before the first domino even falls.
Exactly. And the enterprise... So what here is that this single pane of glass dramatically lowers the mean time to detect threats, your MTTD. If you can see the path, you can cut off the attack faster.
That is huge.
It is. I should mention, though, while basic scanning is free with the SEC standard tier, the active threat detection and attack path modeling require upgrading to the enterprise or premium tiers.
Right, makes sense. So SEC handles the hackers. But in enterprise architecture, hackers are really only half the battle.
The other half being the auditors.
Yes, the auditors. If SEC is your security guard, how do you generate the paper trail to prove to an auditor that the guard is actually doing their job? Especially if you are in, healthcare or defense.
Google provides the Compliance Reports Manager for that. It's this self-service portal giving your internal auditors direct access to SOC, ISO, and HIPAA documentation.
Okay, but documentation is fundamentally reactive, right? It just proves what was done.
True.
Which doesn't really stop a tired developer from accidentally spinning up a server in the wrong region today and violating some massive data residency law.
Yeah.
How do you actively prevent that?
For that, you deploy assured workloads. Instead of manually configuring firewalls for every project, it uses infrastructure as code templates.
Oh, I see.
Yeah, so when a developer clicks Create, it auto-applies pre-written policies that just outright block non-compliant actions at the API level. The system physically won't let them spin up that bad server.
Here's where it gets really interesting. I was looking at this, and these guardrails don't just restrict your employees. They actually restrict Google's own support staff.
What's fascinating here is how this enforces data sovereignty. Take FedRAMP High for the U.S. government, for instance.
Right.
Assured Workloads builds a digital perimeter, ensuring that only specific, authorized personnel like U.S. citizens can even interface with that environment.
And it goes deeper than just access list, doesn't it? They pair this with customer-managed encryption keys -CMEK.
Yes, meaning you hold the keys, not Google.
And then there's KJ key access justifications.
Right. This is where the control truly shifts. If a Google engineer needs to do back-end maintenance that requires decrypting something, They can't just do it.
They have to ask you.
Mechanically, the system forces them to send a cryptographic request to you with a justification. You have to grant real-time approval before their script can even run.
It totally shifts the dynamic. You are automating standard compliant environments rather than building them from scratch. I mean, that replaces what used to be months of manual compliance engineering.
And sheer anxiety, yeah. The burden of proof moves from manual audits to mathematical system-level guarantees. You're compliant by default.
Which leaves us with this final thought for you to ponder. With assured workloads automating strict compliance guardrails and machine learning predicting attack paths before they happen, at what point does human security engineering stop being about writing rules and start being entirely about managing the AI that writes them for us?
That's a great question.
Something to think about next time you check the digital locks on your own infrastructure.